Okay, question number 4. Question number 4 says a car is traveling along a straight horizontal road and the car passes through point A. So let's understand this first visually and then make the graph of it. So they say a car is moving and it moves through point A where its velocity is 15 meter per second. Then it moves with constant velocity, accelerates. For some time, 30 seconds, it is accelerating at 0.4 meter per second square for 30 seconds and then moves at a constant speed here. Constant speed, it moves for some 3t seconds and then it decelerates, and further for some time, t seconds, it decelerates. So your acceleration is now given to be 0.2. So decelerates means minus 0.2 meter per second square. And after for the t seconds, yeah, it passes through point B on the road. So yeah, this is your point B. Here it started from point A, now it passes through point B on the road. So we have to represent this whole scenario on your velocity time graph. So let's begin. So starting it with, on the vertical graph, we have to represent some values. So as we have, it is starting from 15, then accelerating and these decelerating. So let's represent this whole with 5 units apart. Okay, so it seems to be 5, 10, 15, 20, 25, and 30. So starting from 15 and then accelerates for 30 seconds. So let's think of it to be like this. Then after 30 seconds, this point is representing your 30 seconds. Okay, and here the acceleration is, this is 30 seconds, and here the acceleration is 0.4. Now after that, it moves with constant speed for 3t seconds. So represent that. This is your constant speed. And after 3t seconds, for 3t seconds, so this point is representing 30 plus 3t, because this duration is just 3t seconds. And after this, it is decelerating at 0.2 meter per second. So let's represent the decelerating part like this, a less steeper than 0.4. So this is representing acceleration to be minus 0.2. Okay, in time t seconds. So that means this point must be 30 plus 40, as this duration is just t seconds. Trying to make two straight lines for a while. This is t seconds and this is 3t seconds. That's it. Okay, this is your whole sketching of the diagram on a velocity time graph. Now we are talking about part B, and part B says find the value of t But before that, they have given you the distance from A to B is 2750 meter. They have given you to be the distance from A to B. Find the value of t. It seems to be a little simple thing, and if you can think of it, it is actually not very difficult. So let's talk about part B, and that says distance. So distance is given to us from A to B, 2750. Find the value of t. Okay, we know in a velocity time graph, the area under the graph is your distance or displacement. Okay, in velocity time graph, area under the graph is distance. Distance covered. So that means they have given you 2750 to be equals to the area in all this region. But to find out that, we must be splitting this all in different parts. So let's take that. This is your first trapezium. This is your rectangle. And this is your another trapezium. That will provide you the total distance. Okay, so total distance will be equals to area of trapezium 1, area of rectangle, area of trapezium 2. Area of trapezium 1 plus area of rectangle plus area of trapezium 2. So for the first area of trapezium, we need the velocities and time. Time we have already here, and we need velocity. Acceleration is given to us. So before solving this total distance, first we need to find the velocities. So let's do that. I'm just keeping this aside and finding out A is equals to 0.4. So what will be the velocity of this point? So we know acceleration is equals to final velocity minus initial velocity over final time over initial time minus initial time. And we know the difference between the time was 30 seconds here. Final velocity we need to find, and initial velocity was 15. So this will give you, and acceleration is 0.4. So by solving this all, we'll get our velocity to be 27 meter per second. Okay, this is we found from the first acceleration. Now we are going to talk about the last deceleration part. Let's take that. When your acceleration is minus 0.2. So in that case, your 0.2 will be equals to finals minus initial. So final, we don't know. velocity, this one, but initial we surely know to be 27. So final, let's take this to be V1 and this to be V2. So we found V1 here. Now V2 minus 15, because sorry, not 15, 27. 27 was your initial speed here for this region. And time, what is the difference between the time? 30 plus 40 minus 30 plus 3t, that is t. So time is t. So when we'll solve it, we'll get velocity 2 in terms of t, not an accurate value, but in terms of t. And that will be 27 plus 0.2 t. Sorry, minus 0.2 t. That's it. Now let's solve for t. So total distance is 2750. So 2750 equals area of trapezium 1. What is the formula for area of trapezium? Half sum of the parallel sides, a plus b. Normally we call the parallel sides to be a plus b times the height. So what are the parallel sides in the trapezium 1? These are the parallel sides. So one is 15 and one is 27. So 15 plus 27, half. 15 plus 27. And what is your height? This is must be your height, and that is 30. So this is your first trapezium. Now talking about the rectangle. For the rectangle, we know the time is 3t and like the base, and the height is 27. So 3t times 27 plus 3t times 27, as this is 3t and this much is 27. Now talking about the last trapezium, that is your trapezium 2. And in the trapezium 2, what do we have? Parallel sides are, this is your 27 and this is V2 that we don't know about, and your height is t. So let's write that down. Plus half 27 plus V2 times t. And now we'll be because we need to find t, so we will be substituting this v in here. Now your equation will be just be left with t, and you'll solve for t to get the value. Okay, so let's solve that. Solving this whole directly would be a better way to do it, but the only thing that I wanted to redo is to substitute and show you the value of v2. So this will be times t v. What is v? 27 minus 0.2 t times t. Now solve this all. So this will turn out to be, subtracting these two will give you, this will give you 630. plus 27 times 3 is 81 t. Then we have plus 27 plus 27 is 54, and then 54 divided by 2 gives you 27t minus 0.1 t square. Now rearrange this, you will get 0.1 t square minus 108t plus 2120. And then you may, this is in decimal, so you can multiply this whole equation by 10 and you will get t square minus 1080t plus 21,200 equals 0. And then you will solve it, factorize it. You can do it directly, solve this quadratic equation. I'm factorizing it. So the two, breaking the middle term. So if we need to get 21,200, so 1060t minus 20t plus 21,200 equals 0. Taking t common, t minus 1060 minus 20 times t minus 1060 equals 0, and t minus 20 t minus 1060 equals 0. So either t is equals to 20 or t equals to 1060. And if you remember, here in the question it is given to be that t is less than 30. So this is justifying that this is rejected, and this t equals to 20 is your accepted value for this question. Now we have done this, found t to be equals to 20 seconds. Now we have to further continue this question, and further this question says the car continues its motion, its journey from B, decelerating uniformly at 0.5 meter per second until it comes to rest at point C on the road. So now they say that this will continue to decelerate until it comes to rest. That means the velocity becomes 0 and the acceleration, the deceleration is 0.5 meter per second square, and this is your point C. So let's represent this first on your graph. Okay, and I am representing it, just arrange it a little more. Let's represent this. Now it will be decelerating and coming to rest at the rate 0.5 minus 0.5 meter per second square. Now it comes to rest. So find the total distance from A to C. So the thing is, we have already found the distance, or it is already given to be 2750 till point B. Now we just have to add up till point C. So for this reason, we are just required to find the area of this triangle. Okay, and to find out the area of the triangle, do we got the V2? We need to substitute in the value of t to get V2. So let's do that. I'm using a different color because I don't want to move on to the next page. So just solving it here will give you the required result. So V2 will be equals to 27 minus 0.2 times t will be giving you velocity to be 23 meter per second. So this is, here it must be somewhere 23. And what is the time that it is taking? Now they told you about the time. Total distance from A to C. No, they haven't told you about the time. So let's take any time. Let's say this much time that it would be taking will be T2. But for this reason, one more thing we need to find out, and that is the previous times. The T was 20, so 20 times 3 becomes 60. 60 plus 30 is 90, so this is 90 seconds. Then 80 plus 30 is 110. Now what will be this time? T2 plus 110. Okay, and this was V equals to 23. So what will be your area of triangle? I'll write it here and then I shift it to the other page. Area of triangle would be half base times height. Base is your T2 plus 110. And height, we found the velocity to be 23. Now, how could you find the time? As we are given the acceleration, that is the deceleration. So from this information, we can find out the time as well. So let's use that. So the first thing we have is acceleration. We have to be minus 0.5. So let's write that in terms of the final minus initial over final time minus initial time, and that will be equals to 0.5 negative. So what is your final velocity? 0. Initial velocity is 23. Just for this region where this is decelerating at a rate of 0.5. Final time is T2 plus 110 and 110. So their difference would be T2 minus 0.5. So T2 will be equals to minus 23. So T2 will turn out to be 46. Yeah, this will give you 46. So now your area of triangle will turn out to be half. What is your base? Let's take that forward. So it will turn out to be half 46 plus is your base T2 plus 110? No, your base is just T2. No, not T2 plus 110. This 110 is extra thing. That is the whole time for the whole journey. But we are just talking about the one thing, just about the triangle, the last part, because the rest we have already found and is already given, you can say. So 46 times 23, divided by 2. So the area of triangle turns out to be 529. So total distance from A to C will be from point A to C will be equals to 22750 plus 529, and that adds up to give you 3279 meters. Okay, I hope you understand this. In each part where the velocity, where the acceleration or deceleration is given, it means it can be solved out to get any information out of it. So in the first case, we got the first velocity. In the second case, we got the velocity in terms of t. And the last part, when the acceleration was given to be minus 0.5, we solved it to get over the time for this deceleration until it comes to rest. And also the total distance covered in a velocity time graph is area under the graph. So we use that as well. And yeah, that's all working of your question number 4. I hope you understand it. If you have any suggestions, if you find anything difficult, please write us in the comment box. Thank you.